panel again, and now let's bring in the Thermax gentlemen, Vijay and Rajesh. So if you can turn your cameras back on, and as well, Neil and John, if you can join us again, and let's welcome Vijay and Rajesh. Hey, everybody, I want you to know that Vijay and Rajesh got off a 14-hour airplane for a direct flight from, was it Mumbai or Delhi that you're coming in from?
I came in from Delhi. Vijay,
yeah.
He came in.
Look at this. It looks like nothing happened. I'm impressed with you gentlemen.
It was Rajesh who has to go through the travel time. Yes.
We need you to speak a little bit louder, so if you get closer to your microphones, that would be great, because I can barely hear you. But I also wanted to point out, as much of a commitment as it was to get back here from India, you folks are really stationed in the U.S., right? So Thermax has made a move into the North American market. You're not doing it by long distance, is that right?
Yes, we are part of the Thermax Incorporated subsidiary of Thermax, which despite being an Indian company of Indian origin has got subsidiaries all over the world, including here in the U.S. The U.S. subsidiary is about 25 years old and does a variety of businesses besides absorption chillers.
Okay, great. By the way, another point for the audience, since we are a little bit ahead of schedule, we're going to, at the end, invite all the presenters to get back on, so we'll have a big scrum. Everybody will be on the screen, the panel and the presenters, and because we work pretty hard not to bring three of the same thing to show you, so we've got ammonia, we've got lithium bromide, we've got ejectors, and there'll be an open discussion on why one guy thinks his solution is best. It'll be fun. Stick around for that. But let's get into Thermax. And Neil, can I ask you what your most important question for Thermax is?
I guess for Thermax, again, it's economics. And it's important to understand the space requirements difference between the single, double, and triple effect machines, as well as the energy input requirements, as well as the capital cost. Just comparing those three things within your wheelhouse.
And John, your questions?
So it's similar to say about the economics, but beyond that, for industrial processes, how low can you go? Again, I see this technology in commercial applications, but in an industrial process where you're freezing or chilling, can we get usable temperatures?
I'm not sure what happened with the slides there, but while we're waiting to get things straightened out, another point worth making, you gentlemen have a bunch of food processing applications already underway, right? And that's going to be, you'll be showing us those later in your slide set, but lots of really cool food processing applications. So take it away. I think your slides are ready to go, and I'll stop talking. It's your show.
All right. Thank you. Thank you, Skip. Well, so with respect to the lithium bromide absorption chillers, they have it has been around for a while. In between, it had there have been issues and some myths associated with it. But currently where we stand, the technology has definitely made a comeback into the U.S. markets, with Trane having taken up the representation responsibility for us all over the world, including the Americas. So any one of you who would ever want to use these absorbers can contact us or can contact Trane for your requirements. Now, the technology is old, and we have is this better? Are we talking loud enough?
That's better now.
Okay. So essentially, I mean, the technology is largely the same. Which has been used in the past, but we have made several innovations around the technology in terms of range expansion and type of heat utilization and the temperature, the lower end of the temperatures being the chilled water temperatures, which could be established. And currently, one of the primary highlights of this particular presentation is how we are generating 33.8 degree Fahrenheit chilled water temperatures using this particular technology. We will move on to the next slide, which basically gives you the whole range of product which we have. So we go from minus 5 degrees Fahrenheit up until minus 40 with the hybrid chiller, and beyond minus 5 up until 35 degrees is the lithium bromide water cycle chiller, and beyond that is the heating cycle, which is the heat pump application type 1 and type 2, which takes care of temperatures of 90 to 160 degrees Fahrenheit. So on the cooling solution, I think, I would like to update everybody that these absorbers are definitely available below 100 tons of capacity. We, in fact, begin at 25 tons of capacity with the single effect absorbers, which currently have an efficiency of 0.7 to 0.75. And the single effect absorbers can be run on steam or hot water. The steam could be between 0 to 50 pounds, or hot water could be between 175 to 300 degrees. Likewise, when you go with the double effect absorber, your energy consumption cuts down to half. Likewise, responding to the question which was already posed by Neil, the price for the double effect absorber would be roughly 25% more than a single effect absorber. So you have half the energy consumption, heat consumption per ton of refrigeration, and you have about 25% more investment necessary for a two-stage absorber over a single-stage absorber. The COP is, as written, 1.38 to 1.43, and this uses could be steam, hot water, exhaust-driven, or direct natural gas or oil-fired. So all the temperature ranges and pressure ranges are right there on your slides. So I'll move on to the triple effect, which again sees another 25% higher investment in terms of initial cost over the double effect absorber, and reduces the energy consumption or the heat consumption by half of what it was in the prior case. So it's going to be the steam would be about 150 to 400 pounds. It could be hot water, or it could be even higher temperature hot water, that is. And exhaust gases could be between 520 to 1100 degrees Fahrenheit. On the heating solutions, a heat pump type 1 could be offered, which is between 100 to 25 megawatt, 100 kilowatt to 25 megawatt. And that's another product line. And then we have the chiller heat pump, which can simultaneously handle chilled water requirements as well as heating hot water requirements, with a huge saving on input heat energy. And we will see how in the subsequent slides when we discuss the product. And the and the last type of product which we have is the heat pump type 2, which is also known as the heat transformer. Herein, we can actually use waste heat to generate steam, low-grade waste heat to generate steam. That's the heat transformer. Going on, we will very quickly look at the product ranges and their, what they look like and what are the heat sources. So, but to begin with, the single effect type of hot water absorber has the heat source of low temperature hot water between 165 to 248 degrees Fahrenheit. This is available in a capacity range of 20 to 1500 tons, single units, and this has a COP of 0.7 to 0.8. And we deploy the unique twin type design, the unique meaning it's unique to Thermax. We deploy the unique twin type design, which ensures we can recover the maximum amount of heat from the available waste heat hot water source. Moving on, we have the double effect steam or hot water driven absorbers. These run on dry saturated steam of 45 to 145 psig steam pressure, or it could be high temperature hot water from 302 to 356 degrees Fahrenheit. Even this has a capacity range of 50 right up to 3,500 tons and a COP range of 1.38 to 1.43. The double effect direct fired absorption chillers could be run on natural gas or high-speed diesel, that is number 2 oil, and it has a capacity range of 50 to 1,350 tons, and the COP range is between 1.39 to 1.45. The double effect exhaust gas driven absorbers can be deployed with in conjunction with reciprocating engines, can be deployed with microturbines or regular gas turbines, and these can handle flue gases from even from recuperated turbines like the capstones or solar, and these can handle flue gases between 527 to 1,110 degrees Fahrenheit. The capacity ranges between 50 to 3,500 tons, and the COP has a range of 1.38 to 1.43. Then we come to the multi-energy absorbers. The multi-energy absorbers can simultaneously handle several different sources of heat as could be available at a particular premise, and this could simultaneously run on any or all the combinations of these heat sources. Typically, there is a primary heat source which runs the two-stage cycle, which could be dry saturated steam, high temperature hot water, or exhaust gases. And there is typically a secondary heat source, which is low temperature hot water, typically at 185 to 250 degrees Fahrenheit. Now, this could be deployed in conjunction with a reciprocating engine, which would have exhaust gases. The exhaust gases would work as a primary heat source, and the jacket heat, which is rejected typically to the radiator, would act as a secondary heat source. Just to, this is one of the newest products, which has been around for 5 to 6 years, where we already have about close to 30 to 40 installations of this type. Not to mention the overall absorber installation base, which we would have here in the U.S. currently, would be close to about 400. So I deviated a bit, but staying on the multi-energy absorber, there could be a supplementary heat source which could be added together with the primary and the secondary heat source, and that could be in the form of direct natural gas firing or any other fuel. This has a capacity range of 50 to 2,000 tons, and a full load COP in this case would be about 1 to 1.1. Now, remember that absorbers would have IPLVs, which are close to about 25% higher than the full load COPs, what we are demonstrating to you on these slides. The next product is heat pump type 1. Here in the heat source could be, again, there is a low-grade heat source, which could be cooling tower water or process condensate or geothermal water. And there would be a driving heat source, which would be slightly higher grade steam in the pressure range of 15 to 150, high temperature hot water or exhaust gas. This runs on a single stage cycle. Generator and condenser are separated out, and this is available from between 0.25 to 40 megawatt of heating capacity, and sees a heating COP of 1.65 to 1.75, which is the industry highest. The temperature range of the hot water which is thereby generated is about 95 to 195 degrees Fahrenheit, and this can offer a delta T which is as high as 100 degrees Fahrenheit. This is an absolute new product which has been launched close to about 1.5 years back, and just available in U.S. from this year onwards, from January. And this is basically a high efficiency chiller heater. Herein, the chiller and the heating cycle both run simultaneously in the absorber, and the heat rejection happening from the chiller circuit is actually going towards the heating hot water generation. Herein, the driving heat sources could be the same: the dry saturated steam, high temperature hot water, direct fuel firing, or exhaust gases. And the capacity range could be cooling and heating 100 to 3,500 tons, 100 kilowatts to 9 megawatts. The temperature ranges are as follows, and the heating for cooling and heating. This particular product can entail a 23% saving in overall heat input over a standard two-stage machine absorption machine, or it can have 40% of saving in heat input for heating. The salient features for this particular product, which is unique and can be very widely used in the food industry, because in this particular kind of product, the cooling and the heating load have to occur simultaneously, and that is quite possible in the food industry. So a chiller and heater circuit are conjoined, and they are basically, they are both have to be they are mutually interdependent, so you can't have one without the other. In this particular product, we do have the other either-or product, which is the standard chiller heater. But talking about the high-efficiency chiller heater, both the applications, both the utilities have to be simultaneously utilized from the absorber. But having said that, that's the only constraint. But having said that, this has got several advantages, like the easy controllability of vapor flow during various load conditions, and it has got, of course, it's highly efficient. It reduces carbon dioxide emissions, and heat rejection is significantly reduced and can also be eliminated under certain circumstances. And this, of course, uses refrigerant water, so it is eventually a much better form of doing both refrigeration as well as heating simultaneously. The next product is one of the highlights of this particular presentation, which was the 33.8 Fahrenheit cooling using the absorption chiller. This is done by, again, unique to Thermax with the lithium bromide water cycle, and we offer it currently in the 20 to 500 ton range, and this maintains a very high COP as compared to the ammonia absorption chiller, which of course also eliminates any risk or of using hazardous ammonia, which even though we manufacture, we do not apply to the food industry. Chilled water at 33.8, mind you, can be done without glycol, and below that we have we can go even below that using glycol or brine solution. So we actually are we have absorbers which are doing 31 degree Fahrenheit as a standard chiller. The next product, which is also has been talked about, and we would like to state that we are one of the only few, or perhaps the only one, manufacturing the triple effect absorption chillers, lithium bromide water cycle at a commercial level, and offering it in the marketplace. So this has completed the alpha beta phase, and now the product is commercially available again from January this year. The capacity range is 52,000 tons, and the heat source which could be utilized is dry saturated steam, and that would be having a consumption of between 6.2 to 6.4 pounds per hour per ton, with a COP of 1.7 to 1.8. That's what the equipment looks like. The applications, of course, is one part which my colleague Vijay Sharma specializes in, and he is right here to take ahead this presentation from here onwards for you. Vijay.
Yeah. Thank you, Rajesh. Thanks, everyone. Going forward, what Rajesh has been telling about the various products of chiller heater, high-efficiency chiller heater. So this is an extended understanding that where all these absorbers being used as an industry-wise, to start with breweries, which is used typically for cooling requirement in wort process, heating, which is again a sparging process used in breweries, coffee processing also use cooling requirement, and heating and dehumidification. Dairy is again one of the challenging applications that we have been doing, because primary reason is the absorber is giving you a chill water of 33.8 degrees Fahrenheit, which is among the lowest in the absorption technology. So dairy is again a sector that can use this. Tea processing, edible oil. So we just move ahead and see how the application has been used on various chiller applications with the temperature.
Vijay, this is Skip just jumping in for a minute. If you can talk a little bit louder or get a little bit closer, it'll help. We're having a little hard time hearing you.
Yeah.
Thanks.
Okay.
Much better. Thank you.
Yeah. So breweries is the one, again, an application that we have been doing in United Breweries in India, Phoenix Breweries, this is in USA, then Gia Brewery in Nigeria. So the capacity and the temperature ranges you can see here, we are going up to 39.2 again, which is the lowest temperature, cooling water temperatures, and the heat source is used as a steam. The steam is used at 110 pounds, and then the hot water temperatures that we are giving to the application is 176 and 194. So what advantage you get from absorption chiller heater is the hot water temperature you can go as high up to 195, which typically any other chiller heater has got a restriction on the heating output. So the best thing here is the chiller is giving you a cooling 39.2 as well as heating output at a temperature of 194. So this is what the chiller heater is used as a simultaneous application from a single unit. Again, going to the coffee, which is same, giving chill water temperatures of 39 and the hot water temperatures at 194. So coffee is one of the examples. Dairy is again one of the examples, which is, if you see the temperature range, this is 33.8, a very typical example where we have this industry in India, and the chiller is supplied with a capacity of 400 tons and giving you a heating output as well at 185 degrees Fahrenheit. The next is again edible oil industry, which is in Southeast Asia, in Malaysia, and giving you temperatures at 41, 168. So these are all applications that we want to highlight here. And again, how 33.8 can be seen into the regular standard absorber, how we are achieving that is what is being shown here. Is 33.8, we are getting it by using the same refrigerant, but most of the reasons the lithium bromide is not being used as low temperature because the refrigerant itself is water. So what we are doing here is to avoid the refrigerant itself becoming freezed. So we are trying to use lithium bromide as a solution to increase its freezing point, and that is why the refrigerant is not allowed to freeze by adding some lithium bromide. So we are making it an aqueous solution as a brine, as a refrigerant, and allows to run the same absorber at lower temperatures. Another successful installation that we want to tell here is the heritage food industry, again in India, dairy. So these are the temperatures and supplied units here in different parts of the India location, which is the Gokul plant, dairy, and this is a remote performance monitoring that again we have a certain monitoring system. Once it is installed, the monitoring system will be used in conjunction for looking the parameters and temperatures, and it can be diagnosed for any alarms which can seen through these installations. In US, again, Niagara Water Bottling Company is the one which we have chillers. Then we have in Nestle, again, one of the application here in California, which is used for the warehousing, Cadbury, then Ferrero in France, Thai Foods, Preferti Manmile, PepsiCo. So these are the list of installations that we have in food industry, and other applications other than the industry that we serve is education, electronics, engineering, hospitals, and hotels, being the chill water as an output. And that's what we would like to share on the application front. And I think the next slide is thank you from us.
Thank you so much. So let's get Neil and John to join us again. And thanks, gentlemen. That was excellent. While we're waiting for Neil and John, I just want a word to the audience. We do have plenty of time here, and so we are going to do the thing where we invite everybody to come join together for a discussion. One of the fun things about what we do is we're bringing together emerging technologies or large companies that have a new thing, and our whole point is to bring things that folks haven't seen before, and that means the presenters often haven't seen each other or may not even be aware of each other. So during our green room conversations earlier this morning getting ready, the presenters had all kinds of questions for each other just for their own benefit. So we're going to end the show today by having them continue that conversation, just ask questions of each other about their respective technologies. Should be fun. But let's ask questions of these gentlemen all by themselves. First, Neil, what's your first question? And is your mic on, Neil?
Yes. It is
Oh,
this time.
this is great.
I just never turned it off, so
Okay, go ahead.
it was easier that way. One of the traditional problems with conventional, lithium bromide absorption chillers is size, right? So have you guys done anything to address the size? I mean, these things typically, like the size of a freight train, right? In the 2, 3, 4, 500 ton range, just as an example.
So Neil, your question is with respect to the lithium bromide. I presume that you're talking about crystallization and
No, physical size.
Size of equipment.
size. Okay.
Size, yes.
Okay. So a 200-ton absorber, let's say, it again depends upon the type of equipment which you are using, single effect, two-stage, and within two-stage, is it direct fired or is it a plain and simple, steam absorber? Because obviously the component which receives heat by way of natural gas is
I'll tell you what, I'll phrase the question differently. Has any of your new technology reduced the size of the heat exchangers so that a 200-ton chiller today may be smaller than a 200-ton chiller 10 years ago?
Oh yes, absolutely.
That's really the question.
Yeah. There has been size reduction, and that was predominantly done by way of by splitting up the absorber into two parts. So the evaporator in the lower shell is now sandwiched between two absorbers, and that gives us, since people who are familiar with the absorption technology would be aware that the evaporator section sits a bit higher than the absorber section. So that gives us room to tuck in the absorbent and refrigerant pumps, the two small circulation pumps which are used in the technology, and certain heat exchangers. And all the heat exchangers are plate type heat exchangers, so that reduces size dramatically. Earlier days, the absorber manufacturers used to use shell and tube type of heat exchangers. So that's another way of reducing the size, as well as the tube metallurgy now deployed in these in the absorbers are extended, are externally and internally finned tubes. So that enhances the heat transfer area, and therefore utilizes lesser number of tubes. So all of that goes towards making the absorber product really aesthetically. And as you might have seen and noticed from the pictures which were up there during our presentation, these are really much more aesthetically better looking and compact.
Go ahead, John. You were going to ask a question. Go.
Well, yeah. So I was going to ask, what can you tell me about operations and maintenance? I mean, is there any special maintenance that needs to be done on these? What's it take to operate these? Does it take a different skill set or special training for a plant to adopt the technology? I think you mentioned remote monitoring. Maybe that takes some of the skill out that you guys are able to remotely diagnose things. But what can you tell me about that?
Yes, John, actually, if you see the absorber, the beauty part is it's less maintenance involved in the absorber. Absorber typically has got widely accepted and in the market that they do not need much of an attention in terms of maintenance on the equipment other than the regular cooling water treatment that customer has to do it. But when it comes to the absorber as a whole, it does not need any specialized routine maintenance which would involve downtime or something like that, other than inhibitor, which is a corrosion inhibitor added into the lithium bromide, which is a lithium molybdenate. So certain samples, couple of samples are needed in a year to monitor the lithium bromide ppm levels. But beyond that, I don't think we have any other maintenance that involves the absorber, because primarily they are heat exchangers. So being a heat exchangers, no moving parts, and the refrigerant is water, everything is tight, leak-proof, so there is nothing physical as such which is going to involve a type of a maintenance. So that's I would add it as an advantage to the user. And coming to the remote monitoring performance, yes, Thermax is offering remote performance monitoring as an installation for the supply for the standard machines, which can be remotely monitored once it is connected to the web. So the host is created, the website is created, and it is password, and then remotely all the parameters from the heat input to the energy output of the chiller, based on the management that customer needs, it comes with that. Absolutely.
Okay, thank you.
Neil, you got another one?
Cost.
Okay, well, let's ask Peter and Ellen and Don to join us again, and let's extend the conversation. Maybe we can start by having Peter or Don or Ellen ask a question of these gentlemen, Vijay and Rajesh. Oh, you need to unmute your mic, Don. We see you, but we can't hear you.
I'll start. I'm intrigued by the triple effect machine. I'm wondering what your experience with that has been so far.
We have started out 2.5 years back with the commercialization of this particular product. So there are 40 absorbers which are running currently, and these are all in the Indian and the Asian context, and it has been now approved for sales in U.S., the Americas, and Europe as well. Europe is placing the first order this quarter, so the quarter ending June should see the first absorber, triple effect absorber order coming through from Europe, and we are still scouting for our first job here in North America.
So I had a question. There's been talk about chilling and producing chilling, but with hot water as a byproduct or co-product. But what happens if a food processor doesn't have enough demand for the hot water, doesn't have a use for that hot water?
So we have a standard product, which is a chiller simultaneous heating heating hot water jetting absorber. So that's the standard product, which basically has you have the driving heat source, and both the utilities are either or simultaneously met. So the other one which is there, which we talked about, is the high efficiency chiller heater, where the heat rejection happens into the chiller heat rejection happens into the heating cycle. Now, this particular product obviously needs both the conditions, both the heating and the cooling requirements to coexist, and therefore it can be deployed. Does that answer your question, or your question was something else?
Yes. No, thank you.
Let me answer that from Energy Concepts perspective. We've done a couple different type installations. Most usually, we will have a hot water storage tank as part of the system, so we can keep producing the chilling during variable hot water demand. Then when the hot water storage is completely full, we either just turn the unit off, or we have backup cooling tower water at that point, whatever is more important for the customer.
Yeah, so in the chiller heater, in absorber, we have a ratio for the changeover for 30 to 70%. So you can have either 30% cooling demand or 70% of heating, or you can have 30% of heating and 70% of cooling. And if there is no heating demand, the same chiller can run back in 100% cooling.
So let me jump in here. I see Peter has almost asked a question twice. So Peter, your turn. Go ahead.
Did you ever see Bambi, the movie? Thumper's mother said, if you can't say anything nice, don't say anything at all. So I got to be very careful here. Absorption chillers, what I will say nice, both of your products are very impressive, that you have moved them along, and their specs and capabilities, as I say, are much better than what I have seen out there for absorption chillers. So congratulations to both companies. It is more formidable than what I've seen. Let me ask this question that was flows from a comment that was made by the head of a company called Sun Chiller. And what they do is they package solutions of power and cooling, and then they sell them to third-party investors. And this is a little seminar down at PG&E, and he was explaining a single effect as a pickup truck, double effect as a nice sports car, and triple effect as a Formula One in terms of complexity of keeping them going. And that for their packaging, for their partners, even though it wasn't the most necessarily cost efficient, they only did single effect because they wanted that reliability of that pickup truck. So I guess I would just ask, do you see that kind of difference between the different modes of absorption chillers?
Well,
Either.
I'll start the answers off from what I'm familiar with of the CHP market. The double effect chiller requires exhaust above about 340 Fahrenheit because the actual heat entering has to be above 300. So in a CHP scenario, you don't get very much heat above 340 degrees. So it's not so much the complexity of the double effect machine as just there's not much heat in that regime available.
Don, I would like to correct that because recip engines would typically see an exhaust range of about 900 degrees to 1100 degrees, while micro turbines would have anywhere between 450 to up to 520, even if they are recuperated.
Right, 500F. So if you're cooling the 500F exhaust to 340, that's less than half of the available heat in that exhaust.
So you're talking about the leaving exhaust temperature, 340.
Right.
Okay.
Let me jump in here, everybody. It's the top of the hour, and we want to thank the audience for sticking with us. A whole bunch of you stuck with us for the entire 2 hours. And we're going to keep talking. If you have to go because you got to run to the other thing, please do. But this is such a fun conversation that I'm not going to cut it off. So, Don, go ahead and complete your remark, and we'll just keep going until we peter out.
Well, I already completed that the double effect requires heat above 300 Fahrenheit. And so if you're starting with relatively low temperature exhaust, granted some engines have the much higher exhaust that we just mentioned, but a lot of them are in the 500 to 700 F range. And if you're only cooling it to 340, you're not, you're leaving a lot of that waste heat on the table.
I think, Peter, your question was to do with reliability more than anything else. So your question was seeming to imply that, single effect is more reliable over double effect and double effect over triple effect.
Rajesh, a little louder.
Yeah.
Good stuff, a little louder.
So I was trying to calibrate Peter's question. Was more like suggesting that, single effect is more reliable and double effect followed by double effect and triple effect. If that's the line of the question, then I would like to say that, absorbers overall have always been, have had the disreputation of being low on reliability, and that was because it has got chemicals and it runs in a significantly different manner than a centrifugal or an electrical chiller. Now, with the advancements of electronic and controls and PLC that we have, and it has really come a long way. It has been able to take care of. We have been able to take care of stuff like crystallization. Now, Thermax machines are totally crystallization free on the lithium bromide water cycle. I am sure, looking at the product, the ammonia absorber as well, I think it has come a long way. We manufacture ammonia absorbers as well, but that's a different group with cells. So Vijay and I would not be very conversant with that.
But having said that, the products have seemed to come a long way from a control and perspective, and that gives hugely improved reliability on the absorber. So currently, there is no reason why somebody would think of using a single effect absorber when they can get twice the efficiency and lesser heat rejection into the cooling tower, thereby reducing water consumption in case if their heat grade is of a higher level. So if somebody has got 120-pound steam and they want to kill the pressure and reduce it to 15 pounds to run a single effect, that would be outrageous, and there are people who are doing it. That's the reason why I bring that up.
Go ahead, John.
We see that. We see people doing that.
John, you had one?
Well, yeah. So when we were getting ready, we had a short discussion before the audience joined about kind of the use hierarchy of steam or of waste heat. And Neil's comment was it's better to use waste heat to make heat versus, I guess I wanted to throw it out open to the floor. Is that the best use, or to produce chilling, or I guess what are the thoughts on kind of that?
Well, let me attempt to reframe your question.
Yeah.
Is it a valid question anymore? I mean, the thesis was it's better to use waste heat to transfer heat. Are the technologies so advanced that you no longer have to ask the question?
Well, you still do, Skip, because it's the capital cost involved in each stage. A simple heat exchanger versus one type of absorber versus another type versus the ejector. Every time you add a little complexity, you're adding that baseline cost, right?
So how would you manufacturers answer that question?
Let me answer that, since we are both on the deep refrigeration side and on the chiller heat pumping side. It's certainly true that if you do simple heat exchange, which we call heat recovery as opposed to upgrading, you get a very attractive, very short payback period, maybe 6 months or less. But you've limited how much money you can make on that waste heat stream. If you go the upgrade route, your payback is going to be worse. Maybe it's a year and a half, but you'll be making 2 or 3 times more money return on that investment.
If you actually need the heat.
Right.
The upgrade heat.
Or if you need the deep refrigeration.
Yes. Yeah.
Let's take a look at Jeff Johnson's question in the chat, and I see that Rajesh and Ellen have jumped in to answer his question. Is there any discussion we should add to that, or did you take care of him?
Well, or do you want to read that, Skip? I don't know if everybody can see the question.
Well, I'm not sure I can see it, so let's just see. Jeff says, I have a generator exhaust stack, C280. Will the system affect the NOx? So Rajesh has an answer and Ellen has an answer. Go ahead, either Rajesh or Ellen. You want to address the question a little bit more broadly?
I will say something. We normally would take the exhaust after any air emissions control equipment, and when we put an exhaust recovery heat exchanger that we provide, Energy Concepts provides, rather than say an off-the-shelf existing unit, we can design it to take very little back pressure, such as half a PSI. Now, there are cases when the exhaust needs to be a little cooler to prevent harming or long-term degradation of, say a catalyst. So in that case, we could put our heat recovery equipment in front of the catalyst to knock the temperature down of that exhaust. It depends on the scenario. But again, it's not really going to affect your actual emissions. The chemistry, you still are going to have to do whatever air emissions are required in your area, and our equipment won't really affect that.
I want to let you folks know that a big chunk of the audience has stuck around for this roundtable conversation, or this cavalcade of geeks, or whatever we want to call it. But we should probably wrap, because folks do have to run off for the rest of the day. Let's just end with, and this is open, we won't go around the horn, but Does anybody have a final observation you'd like to make? Not a question, just a final observation about what we've seen today. Anybody have a final observation?
I like to think of waste heat as a renewable resource.
Okay. Anybody else?
And my only comment was don't discount any of the technologies, and you need to look at all of them in your particular application every time.
Anybody else?
Not just
I would like to say I look forward to the day that I can be putting up slides showing all of our installations, just like these other two parties did.
That'll be fun.
Yeah.
Okay. And my final observation is we've never in this forum had anybody whose cultural literacy moved all the way from Bambi to Canadian hockey jokes. So we feel very, very privileged. It's been a great day. Thank you all very much. And audience, thank you so much. And we'll see you next time. Next time, by the way, should be early June. And the subject will be filtration for reuse of water at the head end of food processing and produce processing. So we'll see you then. We'll send the notes out, and thanks so much for joining us. Panel and presenters, thank you very, very much. Have a great day.